program of today.
Perfect. Thank you very much, Jean-Francois, and congratulations again to the award winners. So moving on, we are going to start the dual panel discussion soon. It is my pleasure to introduce the co-moderators for the dual panels. Since because of the unique format, we have an academic and someone representing the industry who are both co-moderating the dual panels today. And so it is my pleasure to introduce Ellen Cheville, who is the chair at Bucknell University, and also Randall Restley, who is the VP of Engineering at DigiKey. So I would, it's my pleasure to introduce the both of them, and the stage is yours.
Thanks, YC. Can you hear me?
Yes.
Excellent. I just got a new computer and I'm dealing with the inevitable setup issues. So I'm very happy my audio actually works. So basically, we have some people from various programs that I think are among the most innovative engineering programs in the United States today. One is Ron Ulseth from Iron Range Engineering. There's a lot to tell here, and I can really only tell a very little about it. But Iron Range is an engineering program that was built in the upper reaches of Minnesota to provide access to engineering degrees to students who otherwise could not obtain them, and also to provide engineering talent to the local iron industries that had a very hard time retaining people they hired. And so Ron has done and has been recognized for really creating, I think, one of the world's most innovative engineering programs. Tom and Afshak basically are representing the NSF RED program. RED is a program that the National Science Foundation put together a couple of years ago when they realized that it was departments that needed to revolutionize the way engineering was taught in the United States. And RED stands for Revolutionizing Engineering Departments. And so this was a very highly competitive program. And I'll note that Tony and Chris represent that as well. RED is a very highly competitive program, and every RED awardee is coming in with some unique ideas on how to change engineering programs in order to address 21st century needs. And I will leave it at that. Randall, anything to add?
No, just to say that between academic and industry, things are in such an evolutionary state. And that's always been the case. That's one of the things that attracted me to the field. But more people, electrical engineering roles enrollment is continuing to increase, but not at the rate of, say, mechanical engineering, biomedical engineering, computer science. And so as we evolve the programs, I think it's important also to attract the right people that eventually make their way into industry. So hopefully some panelists will have something to say about that.
Yeah, and then of course, as we know, engineering has been bad about attracting talent from all segments of society. Our diversity is really terrible in engineering compared to many other degree programs. And I think this was one of the things many of the RED programs are trying to address. So we've got questions for both the academic and the industry panelists. Of course, they're not identical, but they're very similar. So we can try to compare views across the two perspectives, and that's what we really hope to do today. So I'm going to jump right in and ask each of the panelists right now to give us sort of the 3-minute elevator pitch about your program, and particularly what's different about your program than what most people might perceive as a typical electrical and computing or engineering degree program in the United States right now. And I'll basically let you go in whatever order you want to.
I'm happy to jump in if you want.
Perfect, Tony, thanks. Why don't you kick us off?
All right, thank you very much for all of you for coming. I'm Tony Machiavski from Colorado State University. And our RED project, we basically wanted to take a holistic view of the curriculum and not think of it as just a bunch of disparate courses. Because from a student's point of view, most curriculum, their day is made up of going to the math department for a calculus class and physics for a physics class and maybe ECE for a circuits class. And none of those faculty have ever coordinated the material that they were presenting to them. And so students sort of feel like they don't really understand how all of this fits together. So we like the sort of joke that we've gotten rid of courses because they were the root of all evil. Essentially, our faculty decided, we came down and said, forget about classes and how things are traditionally taught. Think about what are the main concepts that makes an electrical engineer or computer engineer that flavor, right? And so what we did was we came up with dozens of topics, and we reorganized how we presented them, irrespective of course boundaries, and wanted to make sure that as students went through their day, the people that were talking to them correlated the topics that each of them were talking about, and so that they were all related. In addition to that, every 5 weeks, all of the instructors for the junior class get together with all the junior students, and they do a knowledge integration activity that's meant to not provide new information, but to integrate all that they've learned in the last 4 weeks and show how it is all tied together. And this is typically done around some product, for example, as a cell phone. So in addition to thinking about what students are all seeing at one point in time, we also recognize that as they went through the 4 years of our curriculum, there were certain things that we wanted to have as threads through the curriculum. And so we identified 3 of those. One is what we call a foundations thread. So rather than front loading mathematics, like calculus and differential equations, without any context to the engineering problems we're solving, we sort of thread it through the curriculum, introducing the techniques when you need them. So this just-in-time math idea. A second thread that we identified was creativity. So think about all of the design projects, think about research experience for our students. These are things that we also wanted to thread through the curriculum from freshmen all the way through to their senior year. And then finally, I think maybe the thread that's maybe most relevant for this discussion is we have a professionalism thread, right? So all of the non-technical things that the students need to learn, again, rather than sort of trying to pack it all into their senior year when they're doing their senior design project. So that particular professionalism thread starts right first semester freshman, where we have what we call a simulated internship. Because research shows that students who have an internship are very likely to be retained within the program because they see all of the connections and they can maybe see themselves in what these engineers are doing. And so we wanted to do that very early before we did get a lot of people leaving the program. And that continues with a project practices course in the sophomore year, all the way up through the senior design course, the traditional senior design course that most of us have in our programs. And one of the unique things about this professionalism thread is we have incorporated a program that's called Engineer in Residence. And so faculty realize that they're not particularly good at mentoring students for industry positions, right? They know how to get academic positions, but not industry positions. So we've partnered with our local IEEE section, and we have about 40 working engineers that all come in and spend time in our labs mentoring students, talking about the importance of non-technical skills like communications, working in teams, diverse environments, and so on. And so I'll stop here because there's a lot more that I could tell you about, but I want to give everyone else a chance. Thank you.
Thanks, Tony. Who's next?
I can jump in, Alan. So I'm Tom Martin of Virginia Tech. My department head is Luke Lester. One of the things Alan didn't say about the Red Grant is the PIs have to be a department head. So on our team, I'm considered to be the principal instigator, though. So our RED project was a lot different than Tony's. All the RED projects are different. Ours was, we had a very traditional ECE department where students pick either EE or computer engineering in their freshman year, and then they're locked into 13 or 14 courses until they're seniors, and they don't have any choices of electives. What we wanted to do was change the program so that we could attract and retain a broader range of students and prepare them for a broader range of careers. Our typical student comes down from Northern Virginia, spends 4 years in Blacksburg, and then goes back to Northern Virginia and works for a defense contractor. We had relatively few students who went out to the West Coast or went and worked for companies there and went into a startup. And even our industrial advisory board, we had people saying, look, you're really good at generating folks who are stinking good at what they do, but we have to put them in the lab and they're not allowed to talk to anybody. We need you to generate a few of those folks, but we need more people who can work as part of a broader team. And so we've changed the program so that there's a common freshman and sophomore year for both EE and computer engineering students. And then at the end of their sophomore year, they choose a specialty within ECE. So we have 14 specialties to choose from, representing the research breadth of the department. And then they also have to pick a breadth requirement. And that breadth requirement can be from some predefined section of the department, or it can be a student-defined breadth requirement with departmental approval. So students can pick non-ECE courses for that breadth requirement. The beauty of this is in the past, our students who are interested in some topic that was on the boundary between traditional EE and computer engineering weren't well served by the program. They essentially had to double major. Now they can mix and match between their primary focus and their secondary focus. If a student has an interest that's ECE plus something else, they can do that too. And we're graduating the first cohort of students in spring of 2022. So they're seniors right now. Out of that first cohort, without any juniors or seniors to help them through the process, fully 25% picked that individualized plan of ECE plus something else. So I have a student, for instance, who's doing machine learning as his ECE focus, and he's doing real estate as a secondary focus. And what we have them do as part of the approval process is they have to write a narrative about how those combinations of topics help them further their career goals. So they have to start coming up with a narrative to explain this to employers. So that's our program in a nutshell, our change in a nutshell.
Awesome. Who's next? Thanks, Tom.
I can go. Hi, everybody. My name is Ron, and I'm from Iron Range. Alan did a nice job of introducing. Thank you. A couple of things. I think it was Barnett that came up with the ways of looking at a university. You could have a university who focuses on preparing people for higher learning past the university, a university that focuses people on being ready for work and industry, or a university that focuses on preparing people for service, like the Peace Corps. When the program I graduated from, as a lot of engineering programs in our country, focused on me being ready for higher learning and go on to get a master's degree or a PhD. And those were the skills I had. So when I got to work, I found that I was woefully unprepared for the skills I needed for work. When we started the Iron Range engineering program, we went right to that middle sector. We want to prepare people for work. And so that's one of the things that drove our philosophy. Ours is a BS in integrated engineering, and students can concentrate in ECE, but they can also concentrate in just about anything else you could possibly imagine and attach the word engineering to it. I don't know that you would put real estate engineering out there, but almost everything else. So when we design the program, we like to think of our profession as having an analogy to the three legs of a stool, and that if all three of those legs are strong, the stool is stable, but if any of them are weak, the stool falls over. I like to say when I graduated, the technical leg of my stool was as big around as a redwood tree. And so we think of ourselves as technical people. We also think of ourselves as professional people. And I really like the things that Tony had to say that they're doing in their program. The professional leg when I graduated was maybe about the size of a toothpick. And then we also have to be very design oriented, creative, innovative people. That's the third leg of the stool. And when I graduated, design wasn't even a part of the curriculum yet. When we designed the Iron Range programs, we sought to seek balance across those three legs of the stool. In our upper division program, so here's a note, all of our students come from community colleges. So our program is only the last 2 or 2.5 years of their degree. They all have come from a community college somewhere in Minnesota or in the entire state. In fact, Tom, we get students from Northern Virginia Community College as well. We have in our upper division program 16 credits assigned to professionalism. We have design in every semester of the junior and senior year. And that required cutting a little bit into the technical realm, but our goal was to create this balance so that our students are more ready to be professional people, more ready to be creative. Let's see, just a couple of highlights and then I'll stop. In the professional realm, our students give somewhere between 50 and 100 public speeches during their 2 years. They have a dress code. We work from 8 to 4 and we have workshops 3 to 4 per week. The workshop today is on conflict management. Again, design every semester. Our students can do design in our program where we bring an external project in from industry, or our students can be out on co-op in industry, earning full credit towards graduation and having their design be their co-op work. We have taken the technical part of engineering and gone from the 3-credit course down to 1. So instead of blocks, the lowest common denominator being 3 credits for us, the lowest common denominator is 1. And let's see, one more thing, 2 more things. One, if you think of those legs of the stool and the braces that hold them together, for us, that brace is self-directed learning. And every week we have a 1-hour session on learning how to learn, learning how to manage the project that is my own learning, and graduating as fully competent self-directed learners. And then the last thing I wanted to mention, one of my predecessors here said the importance of having engineers from industry be mentors. We hired 15 engineers from industry to be mentors. We call them engineers in residence. So there's a little bit of an overview.
Thanks, Ron. That's really great. Let's hear from the other of the RED programs before we move on. Do we have Iowa or Florida who would like to go?
I can go ahead.
Please, thank you.
Just joined late, so I don't know where we were, but it's just an introduction right now.
Yeah, we're just, give us a quick rundown of the highlights of your RED program and how it differs really than what most people think maybe an engineering degree program is, particularly from the view of the students.
Okay. So I think from a RED perspective, our program is basically aimed at the change of culture in the departments on how we approach curriculum design, and it basically came from a couple of experience in the preceding year where significant changes in the curriculum when got introduced or discussed, there was resistance to accept those changes, and the mindset was more of an individual working on course designs and having some kind of sense of ownership, and any change into that particular concept was difficult for faculty to accept. So in order to go forward with a more methodical approach, we then got into writing this proposal for NSF Thread program and got funded and had a completely different or maybe more design-oriented approach that was rooted in across the stakeholders team to look at curriculum design and approaching more from a student perspective, more empathy in the design approaches and so forth. So that was the main, you can say, motivation behind behind our project. More technically, we proposed to have cross-sectional teams, we call them X teams, to approach any given particular course curriculum design. And in that particular team, we have representation from different stakeholders that would come together on regular basis, talk about the need for that particular change, and then go into putting together those contexts. And then that was followed by another team, we call them Y teams. So X and Y teams were the main components. And in the Y teams, we had more, the content experts would look at that particular design in more depth and then propose changes. And with the hope that in this process where we have faculty and students involved and also representation from the industry, we have introduced a little bit more broader use of engineering education research within the faculty and also in the design process. So in a nutshell, you can say this is what the guide project is all about, and I will be glad to share more information later in the discussion.
Great, thank you. I think we'll have time in the questions. And can we hear from Florida now? Oh, looks like Chris from Florida is not quite on the call. So let's go ahead and open it up. Hopefully, Sydney, you're keeping track of time here a little bit better than I am.
So Alan, I've got a question for the panel.
Please, go ahead.
So there was an awful lot of talk of integrative technology, integrative experience for the student. And I am reminded of an old definition set that ABET had, and it talked about the difference between a technician, a technologist, and an engineer. And the definition lent itself on the degree of technical difficulty to solve a problem. And I just wonder whether is the integrative program to make better employees able to do things, able to figure out things, able to work together? Is it instead maybe to retain the student, to maintain their interests so they're not so narrowly focused? That's pretty broad. I'll leave it at that. I saw Ron smile, so I think he ought to take the floor here.
Well, that's a really good question. And, I just think the world is changing so rapidly. We've got this fourth industrial revolution, the amount of technology, and the way I've been telling students is computer science is just merging into every kind of engineering, but also merging into every kind of engineering are these skills that we need to succeed in this new world. And I don't know that older definition is going to fit in our future world. It certainly doesn't fit in this idea of being work ready at graduation.
Yeah, that's an interesting point, Ron. It's sort of, there's a joke, we use in higher education with what's the difference between a teacher and a student? It's 24 hours if you're lucky. And I think with the way particularly electrical and computer engineering are changing, it's like, what's the difference between an engineer and a technician? And it might be 6 months if you're lucky in some areas because things are moving so quickly. Anybody else from the RED programs want to tackle that question?
I'll jump in, Alan. I mean, so for me, it takes a slightly different tack. I have an upper administrator that has some data that hasn't been shared that says Virginia Tech students on a whole start off at the same salaries as some of our peers and aspirational peers, but within 10 years, they top out. And that's for VT as a whole, but ECE is such a large program, it has to be true of us as well. So I think what's going on is we were training students that had this narrow focus and they weren't able to see sort of bigger picture things that would lead them to end up being leaders within their organizations. So I think we were doing them a disservice by, as Ron put it really well, the 3 legs of the stool. We were doing the technical part really, really well, but at the expense of the other legs of the stool. So I didn't say it, but we've integrated a lot more open-ended design and professionalism. Professionalism got spread throughout the program, so they didn't think of it as, oh, I've got this soft thing, professionalism over here, and then my technical stuff is over there. But I think it's being thought leaders is an important part of that integrated training as well.
Let me add a little bit more color. The technician degree, according to ABET, was a 2-year degree. A technologist was a degree whereby someone spent 4 years in a technical school, not so much an engineering school. And then the engineer was the 4-year classical mathematics, classical science, and things like that. So the presumption then is the type of problem that one can solve. And so I ask, with the integrative approaches, whether there is the need to better manage one's career or a project that one's on than to understand some nuance to invent a new way of doing something, you know, a new Viterbi decoding.
So let me jump in here a little bit, because I think, you know, the question of what you want to put into that 4-year experience for a student is a critical one. And what we have not done a good job of, I think many people have said this, you know, there are many different pathways after you graduate, right? You know, there's many different things we can do. And let me even push back a little bit about this. Oh, where everybody says, oh, we have to do a lot of design. Well, a small minority of working engineers are actually doing design, okay? And so I think we need to sort of, one of the speakers said the critical piece is lifelong learning, right? Constantly being able to adapt to things. And because, you know, 20 years from now, the jobs that are going to be popular haven't even been created yet. So that's really the question. And that's sort of what our industrial advisory board, we try to get from them, is to say, you know, how do you balance sort of the fundamentals of what is engineering, what is electrical engineering, what makes us different from other disciplines, and how do you sort of instill that sort of view of problem solving and a particular view of how you deal with information within your job, as well as all of the, you know, the non-technical skills. So you try to get a blend of everything and integrate it into your curriculum.
So we've got a question in the chat window from the audience. Aisha, would you like to ask your question, or would you like me to read what's there?
I can speak to it. I heard self-directive learning. I think that's really a key that I profess, or I mentioned to a lot of the students when I'm on the campus, you know, giving talks. So what are some of the examples that you think would be good for students to know, especially for ECE? Now, I might be very biased towards DI, but if you had a set of, you know, self-learning before I graduate, because I think that's how I live my life, but a lot of the students need help and direction. What do you think would be useful to relate to these students?
Well, let me jump in there. First of all, as many different frameworks to consider the acts of learning that they can get as possible. Just yesterday morning, I did a 1-hour workshop with our students on the book that Ulrich Boser published a few years ago. I just put it in the chat, called Learn Better. And in his framework, he's got 6 different aspects of learning. And for students to tease out that there are different ways to consider the different parts of learning and to focus in on any one of those, I think adds a lot of value. And I do not think this is ECE related. I think it's not even engineering related. But another example would be getting students to understand what metacognition is and how to practice metacognitive skills, and just really taking this thing that's been almost tacit in their life and bringing it to the explicit. When we do that, we get them to own their approach to learning, and now they become this consummate self-directed learner.
Well, I also tell them that, there's more learning than besides the classrooms, which is student organization. So I do emphasize that if you're part of IEEE or a part of student orgs, that you're really passionate about, and you join maybe for social reasons, but you should turn them into opportunities and advantage in terms of the self-learning that you're talking about, or even doing group projects. So I don't think we can cram everything in ECE, honestly, because there's so many different train of thoughts, and it's very confusing because of the diversity of the field. But I definitely see the student orgs as being kind of great pathways for learning more than what they do in the classrooms.
One thing that that worked very well for us was the we had over the last several years, we had this practice of in our faculty retreats, we had dedicated a few sessions on learning about the course design. But in that process, what we did was we started identifying student personas. What are different types of students that we have, that we come across, and how do they learn? How do they, reflect when they are in the class? What kind of participation that we have? So, setting up those personas really helps the faculty also reflect on that. That, okay, if I have this type of student who is not going to ask questions, who is going to stay silent, or I have another type of students who is going to ask questions over and over again. And so all these different types of personas we identified, and then we went back into our design table and said, okay, how do we reflect from that perspective and do curriculum design addressing those needs?
We've actually put a lot of time recently into thinking about how do we create a safe environment for students to fail? Because you learn so much more from failure than thinking that, oh, there's always just an answer and here's the steps to get to that answer. So how do we get that, a little bit of that stress, that you get from a failure, but having a safety net for them?
So we've got about 5 more minutes before we go on a quick networking break, and then we're going to come back and get some perspectives from industry. So this would be a good time if somebody on the panel, has something they have to say, but it looks like we just got a question coming in. So let me, Alan, would you like to ask that? I'll let you come on and ask your own question. You'll do a better job than I will.
So, Tony, I was very impressed by your program and hope to learn more about it. Did you get pushback from ABET for doing something so different?
Interestingly, no. And actually, ABET was sort of very positive about what we did, because by breaking down our courses into sort of concepts rather than courses, concepts, and showing how they interrelated, we also have assessments at that very fine-grained level. And so you can think about it almost as a competency-based way of passing through the curriculum. And so they actually really liked that idea of not having courses, but covering all the material that that ABET would want us to cover in our programs. And the other question about in terms of pushback from departments, anyone that's going to do anything like this, I highly recommend reaching out to department heads in math and physics and other places and talking to them ahead of time. But if you do, we actually got quite a bit of positive feedback about them in terms of reorganizing the material that they're teaching, because they still are teaching the calculus courses. It's not that we've taken that away from them, but we have some of our people working with them, in terms of when they're going to teach them and the examples that they're using in their classes.
I wanted to comment on something you said earlier, where you said very few engineers are actually doing design. So to be a good designer, you have to think of multiple possibilities to achieve the same ends. And I see that as absolutely essential for being a good problem solver. So even if they're not designing, they still have to be a good engineer.
There's a synthesis element that I think is so important.
Yeah, and I wanted to jump in on that too. So Donald Shern, who I think was an architecture professor at MIT, breaks it down into problem setting versus problem solving. And problem setting is determining the things that you're going to pay attention to. And then once you've got that problem defined, then solving it. I think engineering programs typically do a really good job at the problem solving piece, but they don't do a good job at the problem setting piece. And when we say introducing design, as I think about that, introducing design in the program is really having something that's open-ended, so there's not a single right answer, and the students have to get some experience with the problem setting skills. So Tony's right, a lot of our students won't go off and be designers, but the skills of designers will be things that they have to use. And we found that our students were floundering in the senior design in the capstone because they'd never been given anything open-ended before. And so we had to move some of that open-endedness down into the sophomore and junior years.
Just a plug here for the ASEE Workforce Summit that's been ongoing now for almost 2 years. In one of the early summits, they came out with a list of the skills that, and they had a list of 5 that are going to be needed for the engineer to thrive in Industry 4.0. And Tom, problem framing was high on that list. Problem framing.
How much time do we have on this session?
We only have a couple of minutes left before we break out into the 2 breakout rooms.
May I throw out another topic? It might be more than a couple of minutes. Okay, so Pat Gelsinger is the CEO of Intel, and having come back from a company for the last 11 years that did software development, having started his career at Intel designing hardware, what he's making the comment of is that tomorrow the world is all software that's augmented with accelerating hardware. And I just wonder, is the electrical engineering education giving up on hardware? The Pong game was 100% hardware. So I just would like to hear from the panel on this topic.
I'll give you a different spin on that, Randall, which is, sorry, my technical background's in wearable computing and electronic textiles. So I spend time working with apparel designers and fashion people. And it's part of this broader area of when you embed computing in a material, in an object, you now have this chance for its response, its physical response, to be much more complex. Okay, so think about the difference of drive-by-wire cars versus, I grew up on a farm. I had an old farm LC. You had a steering column. You turn the steering wheel, you got that much front wheels. With a drive-by-wire car, you get a much more complex response. And that's going to be something both the engineers and the designers have to think about, because now there's more than just a choice and it's fixed for all time. It can change over time and be much more complex. And I don't think we're up for that yet.
Well, ECE is on the leading edge if you contrast it with every other form of engineering when it comes to this new world of software.
So it's now time for our networking break. Sydney, do you want to jump on and explain really quickly the 2 breakout rooms?